Alright, so let's continue with question 16. Nurul conducted an experiment with some plasticine. She molded the same amount of plasticine into 3 different shapes. Alright, so each time the plasticine was in a different shape, she placed it on an electronic balance and recorded the readings as shown in the table below. So she have 3 different shapes. Here, a circle, a sphere, a rectangular cube, and then a square cube. Alright, so the reading on the electronic balance always shows 50. Okay, because it is the same ball, same plasticine, same amount of plasticine. Okay, sorry. So you need to highlight this. This is an important clue. That is the same amount of plasticine. So she did not change it. In fact, it should be the same ball, just that she just changed the shape of it. Okay, so from here, we can see that the aim of the experiment is to find out that if changing the shape affects its mass. Okay, because what she's doing is she's changing the shape and she's checking to see if the mass changes. So the correct aim is number 2. Alright, let's move on to question 17. Lulu prepared a setup shown below. She filled beaker X with marbles to the 150 mark and filled beaker Y with water to the 150 mark. So when the water in beaker Y was poured into beaker X, what would the total volume of marbles and water in beaker X most likely to be? So this is similar to the question that we did in class, the one with the beams and the rice, correct? And we want to see whether do they fill up to 100. So in this case, what is in between the bubbles, we can see clearly that there's actually gaps, and these gaps are actually air spaces. So what actually happens is when you pour the water in, the water can fill the air spaces, so it will not exactly occupy all the 150 volume of space, because some of this water will able to fill in between the space of the bubbles. So therefore, the total volume should be less than 300. Okay, it will be more than 150 because it will definitely be more water. When you add the marbles into the water or the water into the marbles, it will definitely be more than the volume of water initially, but it will be definitely less than 300. Okay, so this should be the answer, number 4. Let's move on to question 18. Sarah bought 2 magnets A and B as shown in the table Alright, let's move on to question 18. Sarah bought 2 magnets A and B as shown below. She made the following statements about the 2 magnets. So they say both magnets have north and south pole. Magnet B is weaker in magnetic attraction than A, and both magnets can attract a copper nail. So we're looking for which statements that are true. So we're looking for true statements. Okay? So let's look at A again. Both magnets have north and south pole, which is true because every magnet, whether it's a ring magnet, a button magnet, they will both have a north and a south pole. Alright, so let's look at the next one. Magnet B has a weaker magnet attraction than A. So magnet B is smaller than A, but it does not mean that it has a weaker attraction. Okay, so the attractiveness of the magnet, or how strong the magnet is not based on the size of the magnet. So B is wrong. So the next one, both magnets can attract a copper nail. So copper, if you can remember, is not a magnetic material. So can all of you write this down? Copper is a non-magnetic material. So therefore, no matter what kind of magnet it is, copper will not be attracted to the magnet at all. So therefore, the only true statement is A, number 1. Question 19. Bernice conducted an experiment to find out which part of a magnet has the strongest attraction. So she labeled the different parts of a U-shaped magnet A, B, C, and D. So what she did was to place them near a magnet near a container of pins, and she observed that part A actually attracted 5 pins. Okay, so which of the following best represents the number of pins attracted by B, C, and D? Okay, so let's recall the fact. In fact, magnets are the strongest at the pole. So let's write down poles of magnets are the strongest. Okay, so poles of magnets are the strongest. So therefore, we have to identify the poles of the magnets. So the poles of the magnets are actually A and D. So both A and D are pole of the magnet. So these two should be the strongest. And initially in the question, they said that A attracted 5 pins. So if 5 pins is the strongest and the most, then B and C will have to have less than 5, and D should have either 5 or more than 5. Okay, so B should have less than 5. So let's look here. Yes, all of B have less than 5. So these are correct. I'm not going to highlight it because there's so many of it. So let's look at C. C should also have less than 5. So the only one that has less than 5 is 1 and 4. Okay, and D should have more than 5 or 5. So the one that with more than 5 and 5 for D is 1 and 4. Okay, so it seems like B, all of them have less than 5. So actually we still have two possible answers, 1 and 2, 1 and 4. So which is the correct answer? So next we need to look at which is closer to the pole, C or B. So because B is closer to the pole, it should be able to attract more more pins than C. So B should have more than C. So now let's look at 1 and 4. B should have more than C. And in fact, only option 4 has more pins in B than C, because B has 3 and C has 1. So C, because it's further away from the pole, is going to attract fewer magnets. So the correct answer should be number 4. Alright, number 20. Rosie bought 3 metal bars, 1, 2, and 3. So she wanted to find out which one of the 3 metal bars are magnets. So she hung each magnet from a string and brought them near to each other, and her results are shown below. Okay, so the key thing is we want to find out which are magnets. Okay, so let's recall, magnets have some properties. So magnets with like poles with like poles will repel and with unlike poles attract. Okay, so magnet with like poles will repel and magnets with unlike pole will attract. Okay, but in order to find out a magnet, we need to highlight on this part. We need to look for repulsion instead of attraction. Why is this so? Because if it's attraction, magnetic material which are not magnets can also attract to magnets. So if it's attraction, it can only show that there is a magnet present, but it does not mean that both of them are magnets. Okay, so in order to determine if they are magnets, we need to look for repulsion. Alright, so we have to look carefully. Bar A and B and X and Y, these two will repel each other. So we can be very sure that bar 1 and bar 3 are magnets. Okay, so this one we can be for sure. Bar 1 is a magnet and bar 3 is also a magnet because they repel. So now let's look at bar 1 and bar 2. So B of bar 1 is attracted to C of bar 2. And in this diagram here, A of bar 1 is also attracted to C of bar 2. So although bar 2C doesn't change the sides, both sides of bar 1 can be attracted to bar 2. But over here, we already determined that bar 1 is definitely a magnet because it's able to repel bar 3. So the possible answer for them to attract each other, although both sides are swapped, is that bar 2 is not a magnet. Okay, so bar 2 should not be a magnet. It is most likely a magnetic material. But definitely a magnet should be bar 1 and bar 3. So the correct answer should be number 4, where all of them are highlighted.